Just gonna list the problem for anyone who's watching on YouTube, which is we are doing the Leetcode problem 141 linked list cycle, which is given a head of a linked list, determine whether or not there was a cycle in that linked list. Okay, so now that we've prefaced what the problem is, let's talk about it. So yeah, what did we think? What went well? What didn't go well? What's going on?
All right. The first thing I was like mainly, can you hear me, Corey?
Yes.
Okay. First thing I was mainly confused about is that there was this position element that was like I was looking on the left in the example for the inputs and stuff like that. So the actual problem says that it returns a boolean, but and the input is just a list node. But it seems to me that like on the example there's a list node as well as a position. So I didn't really know how to implement the position. I did it with just a list node, but I still haven't implemented the position because it wants us to return position at -1 if it's not cyclic. Otherwise you want it's like zero index, so it wants to show you like the position that the cycle does happen. So I'm just trying to figure out like how to go about doing that.
Yeah, that's a good question. I honestly, I completely ignored that aspect of the question.
Yeah,
Let's see. To
weird.
represent a cycle in the given linked list, we use an integer position, which represents the position in the linked list where tail connects to. If position is -1, then there is no cycle in the linked list. So let me just take a look. So I think that that position that they're showing is the cycle. It's like, right? Because the first
Yeah.
one, the position is 1, which would be the first index, which points to that 2. And so the last element points to that. I don't know if they're actually passing that in because they don't put that in as the head. I think it's just a poor way of
Yeah, I figured because it's like it's
telling it.
very that was confusing me because I was like, I know that they want like an output of like true or false, which is fine, but it's just a matter of like, do they want me to return like as well like position at like current or whatever, or it was just a little confusing at that point.
For sure, that's a good, I mean, that's a good clarifying question, right? We talk about clarifying. Probably wouldn't get that weird thing in an interview, but like it is possible that you could have an online coding test and like this would be a problem with that weird position talk, and you just have to figure out like I can completely ignore this.
Yeah.
So what else? What were other people's thoughts? Because I know I saw some fours there. So do some people want to talk about their approach that they took?
I used 2 pointers, like a slow and fast, and just used the fast one by skipping 2 and slow going normal pace. And then if slow ever equaled fast, then it was true, and if it didn't, then it was false. I had to figure out to totally disregard the position thing because I was staring at it for about the first 10 minutes. Like, what? Where do I put that? What is that supposed to do?
Yeah. Nice. That's a great solution. That's like the ideal solution. Did anybody else come up with anything different than that?
I had the same thing. Sorry.
Same thing. No, that's fine. Same thing. I think that's the ideal. So I think I think the other concept is like you could iterate through it, and for each element you could store it in some kind of like set or map or object of some sort, and then you could see whether or not you've been here, like you've actually interacted with this node. Um, but then you have, end memory, but it's end time. While if we do it with the two pointer situation, we can have constant space and end time. So let's talk over the implementation first. I know Jay just did it, but I want to just have it a little bit more visual for anyone who didn't already implement it, because it might be a little bit more confusing. So I got my whiteboard here, which now works with the green screen because I have a real green screen. Okay, so we've got a linked list. So let's say we have an A that points to a B, which points to a C, and maybe the C points back to B, right? This is the idea. So yeah, it is very fancy, Sam, and it is a very big movement, right? Yes, thank you for the comments on the whiteboard. Yeah, you've probably heard of me now because I'm kind of a big deal because of the green screen. Prior to the green screen, nobody knew who I was, but I'm just taking off now. Anyway, so we've got our linked list, right? We've got our head node. So the idea is that we can have a huge influencer. The idea is that we can have, I've influenced 30 people to learn JavaScript just this year. Not really, they were already doing it on their own. I'm just teaching. So the idea is we're gonna have 2 pointers, right? We're gonna have slow and we're gonna have fast. And they're both gonna start at head, which is A, right? So I'll get another color so I can have 2 pointers. We'll make slow go in red. How about that? Okay, so they're both here. And the idea is fast is going to move at 2 times the speed of slow. And so if our linked list is not a cycle, fast will eventually just become null. And if fast ever becomes null, we know for a fact that it's not a cycle, because if it is a cycle, it's going to get hooked. You know, either C is going to point to C or C is going to point to A, and it's just going to get hooked, and we'll never run out of nodes, right? That's the whole idea. So if we're never going to run out of nodes, we know we're in a cycle. So if we're ever hit null, no cycle. So then the question is how do we figure out if we're in a cycle? So we can either be keeping track of nodes that we've already seen. So we go, okay, we've seen A, we've seen B, we've seen C. Now we've got B, but we've already seen B, so we must be now in a cycle. But that's that extra space. Or we can do it like this. So with one of them moving, right, every time fast will finish while A has only gone through half of it. And eventually, they will match up. So let's see. So first iteration, slow is going to move to B. And fast is going to move to C. So let me grab my eraser because my hands are going to get totally messed. Okay, so we'll update this. So slow is B, fast is C. Okay, so then we have another iteration. So slow is going to move to C, but fast is going to move to 1, 2. So fast is going to move back to C. I mean, that's just how it happened to work out this time. And so now we see that that's fast and slow are the exact same node. And if they ever become the exact same node, we know that there is a cycle. Okay, any questions on that? Because that's the core logic of the app. So let's ask questions now, if you have them.
Yeah, so fast, you said, okay, they initially start at A, then slow goes to B, and fast goes to C.
Right.
Then you said fast goes back to C?
Yeah, because fast moves at 2, right? So I'll actually do the movement. So C, this node.next, right? Fast.node.next goes to B. .next goes back to C.
Oh, okay.
So it just happened to catch up. Here, I can add another node too. We can let's try it with another node.
Yeah.
So let's add let's add a D, and then this will still go to B. Okay, so now let's try again. Let's just walk through it one more time. Okay, so we have slow at A and fast at A. Right. Now slow moves to B, so B, and fast moves to C. Right? Now, on the next iteration, slow moves to C, so this is where we were before, and fast is going to move from D to B. So now fast is B, and slow is C. We still with me, Ashia?
Yeah.
Okay, so now we got one more iteration, and so C gets moved to D. Slow gets moved to D, right? And fast has to run. So fast goes from B to D. So now fast is also D. And then we know we have a cycle.
So I guess my question is, we know when okay, so D, when it was at D, it went to B.
Right.
And because B dot next is C, it goes to C, but then it jumps over to D again because of the 2.
Well, we went from C to B. So we went from C to D to B. And then in the next iteration, it went from B to C to D. So it always moves 2. It's always skipping 1 each time.
Okay.
We can look at it again. Okay. So I'm just going to do it with arrows. Maybe that will help. Okay, so we have our A and we have our B. So A goes to B.
Mm-hmm.
And this one, fast, goes from B to C. So it jumps to C. Then slow goes from B to C. The fast goes from C to D to B. So right now fast is on B. Slow goes from C to D. And fast from B goes from C to D. And now they're both in the same spot.
Okay, I got it now. So, okay, so then how is fast going faster than slow?
So we're going to program it to tell it to go twice as fast.
Okay.
Which we can do by saying something like fast dot next is equal to fast, right? So that's going to tell it to move 2 moves at a time.
Okay.
Any other questions on that? Okay, so let's see if we can code it down a bit. I'm just gonna close these markers. That black marker's
So
already
Corey,
done.
you
Yeah,
said
what-
if they do match up, they're a cycle, but if they don't match up, there's no.
Yeah, right. You're exactly right. If they don't match up, there is no cycle. But it's not that they won't match up. It's that fast will reach null, because null is the end of the list. Null is the end of every linked list unless there's a cycle.
Right.
So since fast is going at twice the speed, it's always going to hit null first if there isn't a cycle.
Okay.
That's a great question. Okay, so let's.
That thing where like if head equals null, right? Like that could be sort of like a condition. Well, like in like a while loop, right? It could be like while fast does not equal null. We can
Yeah,
do mere iteration.
definitely. Yeah, I like that, right? Let's start thinking about our conditions. So let's code it out over here in our warm-up area. So we've got our head.
Hmm.
We know we're going to need a fast and a slow. So let's go ahead and start those at the same spot. So we'll say let slow equals head. Let fast equal head. So now we have to come up with our condition. So Marvin says we don't want fast to be null. So we'll say something like while fast, right? Because null is falsy. Let's pretend I just do this. I know some of us might be ready to freak out, and if that's the case, we'll go over it in a minute. We'll say while fast, and then we're gonna have them do their movement. So, right, fast is gonna equal fast.next. Slow is gonna equal slow.next. What is that horn?
Oh, because the fast has to be null in order for it to. Okay.
Yeah. Somebody's car getting stolen? There we go. Okay. I couldn't tell if that was coming out of my computer, so that's wild. All right, so this will move fast at twice the speed of slow, right? So now we can do our little check. Hey, if fast is equal to slow, we can go ahead and return true. There is a cycle. Now, if we make it all the way to the end, there's no longer a fast, we can just go ahead and return our false, because there must not be a cycle. Fast eventually became null. So let's give this a shot and see what happens. Now, I think there's a bug in here, but we'll see. Okay, so copy that over, we'll run it. Okay, so it's acting like we're good, so I'll submit it, but we'll get in there. We go, oh, okay, what's our error here? So the error is,
You didn't
sorry, Henry?
you didn't check for if there was so on your while loop you check for the first pointer.
I
Oh,
see.
yeah, your loop it says
Yeah,
all
but
fast. It doesn't say wall.
you didn't have.
Never.
Yeah, exactly. Can people still hear me? Because I think my internet's cutting in and out a little.
Yeah, we can.
Okay, right? So we cannot read the property next of null. So that means we're trying to call next when this value, fast.next, already equals null. Because we're just checking for fast. So if we have fast, this could be the last link in the list, and then we call fast.next and we have null, and then we call next on null, it's gonna throw an error. So like Henry and Marvin are saying, we gotta check for the next thing as well. So we wanna check while there's fast and fast.next. So while there's these two things, then we know that this will just evaluate to null instead of throwing an error. Because if this is null, we won't even get into this loop. So let's go ahead and try that here. Okay. So we'll run the code again. Still should work because we haven't done any change there. And this time when we submit, we'll see that it works. This is just my internet speed. This isn't the solution. This is like as fast as a solution as you can write. So ignore the 9%. It's the same solution over here, which was like 99%. So don't worry. Here, I might be able to prove it to you. Nah, well, whatever. You see, it's different number. So any questions on this code? No? Okay. That's all right.
Is there a way to do this with like a while loop where you're setting like a current? Is there like a way to do that? Like,
Well, we could probably, I mean, if we wanted to, we could probably keep track of each node we've seen by adding it into some kind of object, either a object or a map or a set. And then we would be checking to see if we've already seen this. So we would just be calling that current.
yeah.
But for this
I think
problem, this
this
is
is
the
like faster.
ideal. Sorry?
Yeah. This is faster for some reason.
Well, it's
And
not faster, it's more space efficient. So this one is solved in O of n time, because we still are iterating through the whole linked list. But this is in O of 1 for constant space and linear time. Does that make sense?
you,
And you can call these anything you want, right? You can also call this like turtle and hare, right?
yeah.
That's kind of fun. Um, but I like fast and slow because then I don't even have to do any thinking. Sort of. I mean, you're still thinking, but it's really clear to me which animal's faster, the fast one. Any other questions on this implementation here? Okay, cool. So that winds that up.